On with, what is it? Areas between two curves. Make sure you've got your calculator out because you need your calculator for this problem. Hence why we have this picture here. So this picture indicates that we're using calculators. It's holding calculators. I'm not being happy. They're actually students of mine from about 10 years ago.
Oh, they're actual students?
Yeah, from Switzerland. That would have been around 2000, hang on, 2008.
You were 7.
Isn't it amazing? Yeah, 2008, 2009, that would have been. Wow, that's a long time ago. They would be all adults now.
Well, that makes sense, but it's weird. Like, 10 years doesn't seem like a long time, but like,
In your life it is,
7
yeah.
seems like such a long time.
It's all, 10 years is, it's all relative to your current age. So you could probably come up with a way of calculating it, like age relativism. Like 10 years is compared with, what, 17? You guys?
Yeah.
17 or 18, yeah. There must be a way, like, is it 17 divided by 10 or something like that? Trying to work out, like, how 10 years is more important for such a big deal for you guys, but for someone my age, 10 years is like, that just
You
feels
were
like.
32.
Yeah, exactly. That doesn't feel like long ago, but for you it was ages ago.
I was in primary school with her.
No, I knew that word because she was more 7, but
Calvin was asking the big questions. Okay, so we're back to find the area between f of x equals x squared minus 4, and g, so that's one function, and g of x equals 3e to the point 2x. So remember, like, when you're graphing these one's going to sit higher than the other. And looking back on the previous pages, because it's been a few days, how do we do it? Remember, the way we do it is if y and y2 are continuous between the lower and upper limit, and y1 sits above, so that's what y1 is greater than y2, meaning function 1 sits higher up than function 2, then the area between the two graphs is given by the integral of the first function minus the second function. That's kind of the overview. Like, see, this one would be y1 because it sits on the above, and this one must be y2. So in this one, we don't know. Oh, sorry. When they give you the graph, it's easy to see. The pink one sits above, the blue one sits below. But when they don't give you the graphs, you have to kind of graph it yourself on your calculator and try to decide which one is y1 and which one is y2. So decide which one is y1 and which is y2 by graphing on your calculator. That's why this is a calculator one. By graphing on your GPC. So we're going to graph both of those, and feel free to graph them on your calculator down to practice your graphing. Okay, so right. So graph them on your GDC, graph them. Yeah, graphing display calculator is what it kind of stands for. So you're graphing x squared minus 4 and 3e. Do you remember how to find e? This is good practice finding where e is. 3e. Yeah. Oh, you can too. Yeah, I didn't think of that. Second ln, but then you've got to put the 0.2 in front of the x. Does it let you do that when you do second ln? Because otherwise, if you just want e by itself, you can do second divide. There's a plain e there as well, and then you just have to do to the power of. But second ln is probably faster, and then you can, if you can insert the 0.2 there. And I'll show you what it kind of looks like. Just to check. Like, I've got mine on Zoom Standard. Remember Zoom Standard? Zoom 6 just sets it from -10 to 10 on here, -10 to 10. So mine's on about that setting, and then this is what they both look like. Which one do you think is 3e to the 0.2x, the blue one or the red one? The red, yeah, good. So you can identify an exponential function. Exponential functions have what kind of thing here? Asymptote, yep. That's an area where it doesn't exist. Because e to the power of any x value will never get below 0, or never touch 0. It'll always be a positive. And here's, of course, our lovely little parabola. So, and they want to know what's the little area in here. They want to know what's that area there. So we are going to need to find out the intersection points, but we also need to define vaguely which one is y1 and which one is y2. So which one would you say is y1? Yeah, the red one, yeah, that's right, this one. You can see it sits above. So this is an example where you have to kind of work that one out. So I do a little vague sketch. Do a quick sketch with maybe that you get some bullet mark for that. That calculator going. And then kind of look like this, didn't it? I've done a pretty sketch there. So that one is g of x. This one is f of x. Decide which one is y1, which one is y2. So g of x is y1 as it sits above. And what we're going to be asked to do is calculate the area between the two. So if you're still not sure what I mean by that, this yellow bit here. We're going to calculate that area using this method. So we need to find out, because the area is the integral of y1 minus y2, but we need to work out what the boundaries of a and b are. So that's the next thing. That's the first thing. So to find a and b limits, find the points of intersection. And remember to do that. Does anyone remember what you pressed on the calculator to do that?
It's been a minute. It's second out.
That's it. And 5. Is that intersect? Yeah, that's right. Second calc intersect. Let's do a demo of that. And there's 2 of them we've got to find. We've got to find the one here. You only need the x coordinate, but feel free to record the y coordinate just in case it's useful later on. But the x coordinates all we need because a and b are x values. So I'll just save that for now. And now let's grab our calculator out. So yeah, remember, so you go second calc, 5, select intersect. What do I do now? Good guess, because sometimes you do that, sometimes. At the moment it's asking first curve.
You press enter.
Enter, yep. Now it's asking second curve.
Enter.
Enter. And guess, question mark?
Enter.
Enter, yeah. So basically when it's find the intersection, it's second calc, enter, enter, enter. And what it does is suddenly it'll flash up on the closest one to where it was. So that's this one here. So what's our x coordinate? And do you know what they suggest? Because these are kind of pretty small numbers and the area can be affected by rounding too much, when you find them to more than 3 sig figs. Because otherwise, if you do 3 sig figs, they recommend it's a little bit inaccurate. So round to more sig figs. So I tend to write out the whole thing to begin with. So the first one is x is negative 2.14. You don't need the y1.
I got 4-1.
Oh yeah, 2.418568, something like that.
Mm-hmm.
Yeah. 2.418568. So I'll write this one, then I'll write the second one, and then we'll make a note. At least they say at least 4 sig figs when you put it in the integral, but maybe write it out some more just in case. And then the other one. So what's interesting is then how do you find the other one? I go second calc, intersect. And then so if I press enter, 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 it's just going to find this one again. So, yeah, move it. Yeah, that's right. Exactly. Good memories. Move it to the right just so that it's a bit closer to the other one. You could put it right on it, but it's just got to be closer to it. And then what do you do? Yep, enter, enter, enter. Yep, and then you'll see it flashes up here. And then you get a certain number, which I'll write up on here as well. There's any other ones. This one is like 3.3. So interestingly, which one of these is A and which one is B?
A is any tats I can't look at you.
Okay, guys, what did Sarah just say? Sarah just pointed out which one was A and B.
A is -2.
Yeah, why is that?
I already did the lower.
Oh, yeah, you like it so obvious. So, okay, fair enough. Thank you. Okay, yeah. So A is the A, that kind of thing. So write to more than 360. More than 360 for better accuracy.
Wouldn't it be precision, not accuracy?
Oh, hang on. That depends. Accuracy is meant to be how close is something to the true value,
Or better.
and precision is meant to be like how close together are a big group of results. But then that's according to a chemistry textbook I read when I was about 21. So precision can be defined in other areas in different ways.
Because in physics we would call that precision.
Oh, really? Okay, call it precision then. Yeah,
But
because then
it's
be
not
consistent with
physics,
physics.
So, I don't know. Is there a math definition? Who cares? That's more.
Yeah, so precise was meant to be like, say, all your results are really close together. Or like, imagine this was a real result. This is in chemistry. If that was a real result, something being accurate means that your tests all came pretty close to the real results. Something being precise just means they were all close together. Doesn't mean if they were close to the real result or not. But that was in, yeah, the chemistry textbook back in like the late 90s. So it's probably completely been redefined, so you can ignore my one. For better, what do you want to call it then?
Who cares? For better results.
Consistency. Better accuracy. I'll just put / reliable.
No, I just
Reliability. Whatever makes sense to you. Yeah, I'll just put whatever.
Oh my god, reliability has the word liability in it.
So that's nice. So we've just found some important things.
intersection is the word section.
So we start to
And ion.
this kind of thing. So just reminding you, because you might have forgotten, it's A, B, and then you do Y1 minus, oh.
Intersection is more of an intersection.
So because it's been a bit of a time since we kind of did this last, I'm just reminding you what the general thing is. You find to find the area between the two, you define the limits, like where the points of intersection are, the area is bound by, and then the top function minus the bottom function, dx. And we're going to do this just in our calculator. So.
Why can't the top function be y2?
Because that just makes more sense to you.
Yeah.
It's 9, isn't it? And it was because remember when we did that investigation where we had the rectangles. So oh gosh, come back. Okay, back to here. So when we had this one, to find the height, we kind of always did the top value, the top y value minus the bottom y value.
Yeah, y2, y1.
Oh, I see. So y1 minus y2. Yeah, I know. They could have just defined it and called it y2 minus y1. I get you, because then it's more consistent with coordinate geometry formulas.
Yeah. Then you do like y2 like y1 of x, like y1 to 5.
Then you can just commit to memory y2 minus y1. Yeah, I get you. Okay, so now we're just going to do the same thing, but we're going to plug in the actual numbers. So we've got our integral. So we've got to write out those nice purple numbers. They say in the textbook, they say at least 4 sig figs.
I think we
Do them all if you want. Yep, sure thing. Go for it. So if you want to go further, you take it further. In the textbook, they say at least 4 sig figs. I'll just do it to at least 4 sig figs. Then you plug in your x and your y. So the top function is the red one. So g of x, 3e to the 0.2x. You always subtract the bottom one. And the bottom one is x squared minus 4. So we're going to need to put that little thing in brackets. Dx. So see, why did it? What if I didn't put brackets? What would be wrong about me not putting brackets on the green function?
It would be. It's just be plus.
Yeah, exactly. Yeah, exactly. It leaves minus the whole thing now, doesn't it? Which is what we're supposed to do. Yeah. So minus x squared plus 4. If you expand that. If you didn't, then it wouldn't. Right. So now, what's awesome? We just pop this in the calculator, just like that. We don't need to do any simplifying or anything. We can just work it out. And I did it the other day, but I did it rushed, so I think my answer's wrong actually. Oh, and
We could do it like that.
oh no, what am I doing?
Because that happened to me too.
Yeah, oops, I just forgot to get out of there. Math. No.
Yeah.
Owen, what should I put in my thing? Pop it in your calculator now. Practice.
26. Like the sound of
I got the same as you. Okay, good. And we can write it out unrounded and then round our answer. Okay, guys, pop it in your calculator. Good on you. Owen, she's doing it.
Is it when the dog barks or when the dog bites?
Bites, dude.
Pop this in your calculator.
It's
What do you,
bites.
I don't know what you're talking about.
That's my answer. Sabah.
Oh, a song. Is that a Christmas carol or something? Yeah.
I think it might be like I have a Christmas book for piano and my favorite things is in there. Like it's not a Christmas book.
What?
Question, how do we get the little,
Math 9.
thank you.
Math 9, yep. And then it's all set up for you.
Wait, so what does the answer signify? The area?
Yeah, that yellow area that you can't see because I scrolled down. That area between those two curves, between those two x values.
Everyone's pointing these. That's great for you.
That's great, Grace.
Okay, well I got. Oh my god! Nobody else said anything. So
Roasted.
it's went ahead of me.
I got it, but I didn't want to keep it.
Okay, I just want to speak.
Great.
So remember, like it's always good to write the unrounded answer and then round to 3 sixes. Unless they say something else. I do.
If I would have done it, I wouldn't have done it.
Yeah, you do. So if we had to give any units, what would we write? Unit squared, yeah, I think. Unit squared. And maybe let's make a note of at least.
Really love Christmas.
Let's make a note of this. At least 4 sixes.
That's true.
You can't even go with like 5. Yeah.
So a lot of them clues between lunch and dinner. Yeah.
And they call me Sundays.
Okay, cool. So you got that. So see what I tried to write here in green was I just tried to make it. I sort of did it here, but here at least 4 sixes for those, putting in those limits. Otherwise, it becomes a bit inaccurate, unprecise, unreliable. I don't know. Imprecise, unreliable.
But I need to keep it
Just becomes wrong. Yeah. So now let's do one more of these ones. What if the graph is not continuous over A and B?
Yeah, C.
Yeah. So imagine like if the graphs kind of crossed over each other, and like at some point one function's higher than the other, and then suddenly like there might be a curve, there might be an exponential function, and a curve that cuts and then goes under, and they want 2 separate areas.
I do. What?
Yeah. What do I mean by that? Let me show you one.
What page? It's not a present.
I love it.
Okay, so I'll just show you an example of one. Negative ln. What one are we doing? X plus 4. So the one we're going to be asked to graph is negative ln. Oops, x plus 4. See So this one, negative ln x plus 4. And then the other one will be this one here. So if you, so Lauren, graph these ones, graph this one in y1, graph this one in y2.
Wait, why are there lines after B?
After B?
That's easy to just work out where the separate area is.
Oh, yeah. So at the moment, I'm just trying to demonstrate what do I mean by these graphs. Yep, and then we'll fill in those little bitsies. So some people, because it's not really clear what I've said about in terms of what the graph is. So we're just graphing them first because you're going to need to later anyway. Minus 4x squared, just to point out what do I mean by the graph. One graph sits above the other and then it swaps. So we'll graph those two, negative ln x plus 4. So use the negative button here, not the minus button. And then x cubed minus 4x squared plus 2x.
Why did I get a thing with it?
Did you use minus instead of negative
Weird.
on the ln? You've got to use negative. The
Oh,
negative
I
button.
definitely used mine. You just
Ah.
said that, didn't you?
Yeah. So see what I mean by, for example, here? Yeah, so see how this graph, to be honest, is kind of more like this, ln graph and negative ln graph. And this is a cubic that cuts up here. So see the area between the two is here and here. So what we have to do is work out this region first, because at this point the red one sits above the blue one, and then separately work out that region, because here the blue one sits above the red one. So we just have to do two separate integrals and then add them together to work out the overall area. So that's what I mean by this thing. What if the graph is not continuous for all of A and B?
I said plus C, you told me yes, but it's wrong.
Oh, okay, so easy. Just work out this, and you might not realise what I mean here. Easy, just work out where the separate areas begin and end.
You didn't even let us guess.
Yeah, it's a bit of a weird one. So work out where they begin and end. Like basically, where do they cross over and where do they intersect each other? Work out the areas separately, and finally add them together. Yeah, that's right.
It's so beautiful being able to actually graph on a calculator.
Add them together.
No, it's always a struggle.
So first of all, here it just wants you to write down an expression which gives the areas of the region between fx, between those two functions. So that, if I write down an expression, it's going to be ask us to,
Let me just do that twice.
yeah. So basically write down an expression. They want us to just do this bit. But remember, there's going to be two of them added together. So they just want us to work out this thing, like, just write it out, and then plus the other thing. And then the second part is going to be then work out the answer, which is the number. So we're going to have to do that. So to graph it, so to do that is a good thing to do is to graph them as we just did already. So that's handy if you've graphed it already. If you haven't, you might want to do that because you're going to have to graph it. And then do a quick sketch of it. So do a rough, vague sketch of it and try to work out which are the areas. Where are the areas between the two? So you can identify what points.
Yes, we did.
So we've got the negative log. So the negative log kind of going down here.
Nationals Day 4.
And the negative log, by the way, what does it have here? So exponentials have
An asymptote.
an asymptote, yeah. So exponentials have asymptotes at that are horizontal. Logs, because they're the inverses of exponential functions, have vertical asymptotes. Looking at this here, x plus 4, what do you think? So normally the asymptote would be
Negative
x is
4.
0. Yeah, so now because it's been a horizontal translation, 4 units left, it's at x equals negative 4. So just trying to remind you of a bit of function stuff over here. So a log normally would have an asymptote at x is 0, but because of the x plus 4 in brackets, it's a horizontal shift, 4 units left. So just pointing out what that is. That's not important to this question, but let's do our cubic. Our cubic kind of crosses over, sort of vaguely here, and then vaguely down there, and goes up infinitely that way, down infinitely that way too. Like it would probably crosses the asymptote, but that's okay. So that's a cubic, and that one is g of x, and the blue one is f of x. So we're going to, the area is going to be here, There's two separate areas, the yellow area, there, I'll do another one, and a blue area. So yellow area and blue area. And we're going to have to separately work those out and add them together. In order to do that, we have to work out what these points of intersection are here, here, and here. So 3 points of intersection that we need to work out. Sometimes, you know, like one thing I forgot to point out, a way of kind of like showing you're working out for finding the points of intersection is just put the functions equal to each other. So maybe that's a good idea. Because imagine you had to go working out finding points of intersection.
Wait, why make them equal again, Miss Kennedy?
Technically, when you find the points of intersection, we're just doing it on the graph. But if you wanted to show working out for it, it's like this. Whatever you had to do it by hand for some reason, like you had easy functions, then you set them equal to each other. So if it was non-calc and you had to find the points of intersection, you probably would have had just normal polynomials, like no log functions maybe, and you set them equal to each other and solve for x. But you'd have easier functions next to be able to do that with, like maybe a linear and a quadratic. So it would have been really easy to work it out. Yeah, so if you just had a linear and a quadratic, you would have been able to set them equal to each other and solve that way. But these are a bit awkward, so, and it's intended to be done with calculator. So we have to, on our calculators, find them. So we go second calc, intersect. That didn't work. It's a bit slow, is it? My calculator's playing up. Second calc, intersect, number 5. Just go whichever one you want to do first. I just do enter, enter, enter. So we've got one here, negative 3.6, blah, blah, blah. And then you go second calc, intersect, arrow closer to the other one.
How come you didn't write that one?
I will, I'll just do it all at once. Like when I write, the calculator disappears on me. Enter. What did I didn't do something. Oh yeah, I did. Okay. 5. Oh, I pressed value, that's why, sorry. Second calc, I should have pressed 5. Enter, enter, enter. There's that one, and then you can arrow over first if you want, but I just do second calc 5, and then I arrow across. Doesn't matter, as long as it lands where it should be. Enter, enter, enter. So see, just pointing out, you'd have to do 3 different ones and write them out to lots of decimals. So we're going to do that now. Oh, and then, yeah, see, part B is find the area. So find the area just means plug it into the calculator. And we're just setting up the thing we're going to plug into the calculator in part A.
Wait, you're all fine. You want to go for?
Yeah, so then you write out your 3 x coordinates, okay, points of intersection.
I don't think I'm working out like you.
You would have a nicer one. You'd probably have a quadratic on one side and a linear, and then that's going to be an easy one to solve. So those numbers probably go on and on and on, but like, you know, that's that point. So we've got to, you might want to make a point of how to find the points of intersection. So what we did was we graph the functions. Graph. And at the top, graph for functions and sketch. Do a rough sketch just because it helps you to see where are the areas, so what do you need. You also need to realise which one is for each area, which one is the Y1 and which one's the Y2. That's what we did. Find the points of intersection. Intersection. Yeah, this board's gotten worse. It was bad, but anyway. Okay, so second calc intersect. and enter. You might just want to point out that you have to do enter, enter, enter as well. A bit more space to do that.
So it's times 3.
Yeah, enter times 3. If you're like me and you take that literally, you write enter and then try to type times 3. So we've done that, and that got us these things. For the first region, g of x is higher. Yeah, so maybe let's make a few notes on that. For the first region, the red one is higher. For the first area, g of x is y1. For the second area, f of x is y1. So that's for the first area, g of x is y1 because it's higher. For the second yellow area, f of x is y1. That's what that's pointing out.
This one.
Yeah.
Can I know what the end answer is? Because I can't.
Did you get?
Did we put like a negative?
Did you get number between 4 and 6?
Yes.
Then you probably right there.
Mine is
For my answer, I used 4, 6, 6 in my limit.
I used all of them.
Yeah, use all of them. It'd be interesting to see how much it changes.
That's a lot.
I think they say like 3 is kind of like there's going to be quite a big difference, but once you get 4 or beyond, I think they must be pretty close together. So we set up our little integrals. Use 4 sig figs for your limits. Use at least 4 sig figs for your limits. Sorry, you can use more. Use at least 4 sig figs for your limits. So the limits will be different depending on which region you're doing. Let's see the first one. So we've got in the case here. 1, 2, 1, 2, 5. This thing. It's a lot of the writing, isn't it? Which one is the cubic, the red one? X cubed. That's always a minus. And then put the log in the brackets, negative ln. Store. You've got to have a lot of brackets, don't you? That's the first region. So all we've done so far is the first region. Now we've got to, also to that, we've got to add the second region. Plus, you've got big more space just right below. I'll try to put it all together. And then you've got different limits this time. 1.205 is the bottom limit. 3.174 is the upper limit.
Ew.
Oh. Dropping down to the sound of voice.
Oh, yesterday.
They used to be mine.
That's an awful.
So that's our answer for A. Because they just wanted an expression for evaluating the area, and then in B they want us to pop it in. So I did that just because in the textbook they've got a few questions like that. Find an expression, just so you know what you mean. It's like this business. So that was most of our work. And now we just pop it in the calculator. So yeah, practice popping that in the calculator because it's awkward. Notice for the first one, for y1, you don't need to put that in its own little set of brackets, but you can if you want. But the second one, for sure, pop it in its own set of brackets because of that bed mass issue. But it's okay if you don't put the first one in any special brackets of its own. And because my board is a bit dodgy, I just didn't want to have to write another bracket. But on my handwriting, I do have a second bracket in here, just to remind myself for the second one to have a bracket. And hopefully you get a number between 4 and 6. I sort of separately calculated the areas and then added them together.
Yeah, that's what I'm doing.
Yeah, because it's a bit awkward, isn't it? You can put it all in the calculator if you're happy enough to do that. That's allowed. Just make sure that you don't round anything early. Yeah. You don't need to open it, just to relax it out. So don't round early.
Oh, they switch.
So basically don't round early. That's really important. Otherwise you'll get a big error. So that's a big commitment, doing a question like that. And that's the end of this particular lesson. I'll just click stop on here so it'll start converting. But we'll do a bit of volumes of rev as well. But